Now that I've taught you to do a few things with truth tables, time to give you a little advice, which is also going to expand your education of propositional logic in general, particularly if you haven't been exposed to it before. As I've already been over in class, the conditional that we use in propositional logic, called the material conditional, also known as the horseshoe because of its shape, doesn't exactly model if-then thinking. So there are inferences you can make with the material conditional. There are things that follow from material conditional statements that don't really follow if you thought them through in English. Here is actually a law of equivalence. So these two things are equivalent for any formulae of the following structure. If A, then B. That is equivalent to, so double line there, I mean equivalent to this. Not A or B. If you give me the $20, I'll go buy you the record, doesn't seem to say the same thing as you don't give me $20 or I buy you the record. Those simply do not, they just don't seem the same. And indeed, we could go much further, and we will eventually go much further with the paradoxes of the material conditional, explaining or trying our best to ramify about why exactly that's weird, clarify, derive the implications of, etc. And so, because basically the material conditional just means that is what it means in our logic to say they are equivalent. They will always be true and false in all the same cases. They will never have a split in truth value. So because those will never have a split in truth value, this just means this and this just means this, even though it doesn't seem in our everyday thinking of if-then that it is equivalent to this particular disjunction, i.e. antecedent false or consequent true. But think about the truth table. What do you do when you hunt on the truth table to construct a conditional? You start by trying to look for those cases where the antecedent is false, making the whole thing true. Then you look for those cases where the consequent is true, making the whole thing true. That means at least one of, and of course this or means at least one of antecedent false, note the not, or consequent true. B and B. So that's the equivalence involved. But let's, with a truth tree, then demonstrate that thing on the left entails thing on the right. Later on, I may go back and show you that thing on the right also entails thing on the left. So really, we should have turnstiles running both ways here to indicate equivalence, not mere entailment. But let's just go through more truth tree practice right now. So, as always, first line. For an entailment proof of the truth tree, put the entailer, or however many formula are listed over here, on the top of your truth tree. So if A, then both B and C. That's how you could say that in pretty natural English. Well, if A is true, then both B and C are too, right? Okay. I, in fact, would permit, if you look at the rules, you just to go straight from this to this. That would be a two-line truth tree that would be correct, wouldn't be very revealing for the purposes of practice and explaining what truth trees are. So here's another thing you're allowed to do. Because they are equivalent like this, this just means this, right? So it means two possibilities. One of two possibilities has to be true. The antecedent's false, or the consequent is true.